Hey, this is part 2 of solving quadratic applications. So remember today when we went over number 5, we were a little thrown off here because we said at 6 seconds that the height of the ball would be 375 feet. Okay. This led to the confusion of when we found the maximum height of 347 feet. Well, I found the reason for that mistake. So if I plug in 6 into my function, I actually don't end up with 375. I end up with 311. So this should be 311. Okay. Meaning when we go down to the question that says, does the table of values shows you it has a maximum height? Well, all we see now from the table is that we have a height of 311 at 3 seconds. So when the ball is going up the parabola, and then a height of 311 on 6 seconds when the ball is going down the parabola. So when it says, does the table of values show you the maximum height? We would say no, okay? Because it only shows us the graph of when the ball is going up, and then it shows us when the ball is going down. We never see this part here of the vertex. Okay? So that means when we did the formula for max height, that was correct, that the max height is 347 feet. Okay, so I just wanted to clear that up. And again, thank you for pointing that out. And I was able to fix this mistake for future notes. Okay, so now let's go ahead and finish the rest of them we didn't get to today. So number 7 says a half pipe ramp at a skate park is approximately in the shape of a parabola. If X stands for the horizontal distance in feet from where the skateboarder starts a ride on the half pipe, and Y stands for the height in feet of a skateboarder from the ground, then the position of a skateboarder on the ramp is given by the function Y is equal to 0.42x squared minus 5.67x plus 20. And it says to find and interpret the vertex. Okay, so what we need to do first is we need to draw what our image looks like. So if I just draw my X and Y axis, it says that the half pipe ramp looks like the shape of a parabola. Okay, so here's my parabola that is representing the ramp. Okay, so let's see. So it's asking us to find the vertex and to interpret that vertex. So this is the first problem where we have a parabola that is now opening up, meaning when we find our vertex, we're going to be finding the minimum value. Okay. So we're going to continue using the vertex formula. So negative b over 2a, and then plugging in whatever we get for negative b over 2a back into our function. Okay, so our function y is equal to 0.42x squared minus 5.67x plus 20. I'm going to go ahead and label my a and my b values since that's the only values we're using here. So my a value is 0.42 and my b value is that negative 5.67. So plugging it into my formula, I get x is equal to negative b over 2a. Negative b, negative because of the formula, and then b is also negative, tells us that those two negatives are going to end up canceling out to be a positive. And then 2 times a is 2 times 0.42. So that first one we said, okay, it's just gonna become positive, and then that bottom one, 2 times 0.42 is 0.84. And if we plug that into our calculator, we get 6.75. Okay. So now we are going to take that number and plug it into our function. So y is equal to 0.42 times 6.75 squared minus 5.67 times 6.75 plus 20. So anywhere I saw an x, I plugged in 6.75. Okay. If I plug all of that into my calculator, you should get 0.87. This means that my vertex is 6.75, 0.87. Okay. Remember that our x value, right here in our problem, stands for the horizontal distance in feet from where a skateboarder starts a ride on the half point. Okay, so this is the horizontal distance in feet. And the y stands for the height in feet of a skateboarder from the ground. So if we were to interpret this, we would say at 6.75 feet of the ramp, they're at the lowest height of 0.87 feet. Okay. So again, they are, once they have already passed 6.75 feet onto the ramp, so they start the ramp up here, they're going down here for 6.75 feet, eventually they'll be at the lowest part of the ramp, which is only 0.87 feet off the ground. Okay, so we're going to write that in a sentence. So at 6.75 feet of the ramp, they are at the lowest height of 0.87 feet. Okay. Now let's look at number 8. Number 8 says, in science class, students were asked to create a container to hold an egg, which they would then drop from a window. The function h of t is equal to negative 16t squared plus 25 gives the container's height h in feet after t seconds. Okay. So what it wants us to do is it wants us to see how high is the window. Okay, how high is the window? Meaning we have not dropped the egg yet. Okay, since we have not dropped the egg yet, that means our t for time is going to start at 0 seconds. So what we're going to have to do is plug in 0 for t. So we have h of 0 is equal to negative 16 times 0 squared plus 25. This first part, the negative 16 times 0 squared, is going to cancel out to 0, meaning we have the window height of 25 feet. So we would say that the window is 25 feet high. So that's our starting point of where we are dropping this egg. Then it says, find the maximum height of the container. Okay. So again, let's visualize our diagram here. We have a window that is 25 feet high. This right here is representing our ground. They are throwing a container holding an egg out of the window, and it's eventually going to hit the ground. So in order to find the maximum height of the container, we need to find that vertex right here. So in order to do that, we're going to use the vertex formula, which remember is negative b over 2a, and then we plug in whatever number we get back into the function. So I have x is equal to negative b. So if we look back at our original problem, so let me rewrite this over here. Negative 16t squared plus 25. Notice that we have the value for a, but we're missing the value for b. Because remember, the value for b is the one that's going to be attached to the single t. And this value of 25 is our c value. So that means when plugging in b, we're going to have to write 0. So going back to our formula, we have x is equal to negative b, so negative 0, over 2 times a, 2 times negative 16. Okay. Remember that 0 divided by anything is 0, so our x value is 0. We're going to plug in that 0 into our function to find our y value. And notice that we did that in the first question here. So again, I'm going to have y is equal to negative 16 times 0 squared plus 25, which is going to give me 25. Meaning that the vertex is at 0, 25. Okay? Meaning the highest point that the container ever goes is that 25 feet. Because we're dropping the container out of the window. When you're throwing a container holding an egg, that's in order to protect it, you're not going to throw it up and then down. It's going to go straight down. So meaning we could even draw our graph looking more like this to visualize that you're dropping out of the window straight to the ground. So our vertex would have to be that window. Then it says, how long does it take to reach its maximum height? Okay. Remember, our x value, in this case the t value, represents time. Okay. And if we were to label that vertex, we have t, comma, h of t. So time and feet. So seconds and feet. So how long is it going to take to reach 25 feet? And it's going to take 0 seconds. Okay. So it will take 0 seconds because we are already at that maximum height. Okay, so that is our answer. Okay, and then last question here, number 9. Says a child is jumping on a trampoline. His height h and feet at time t in seconds can be modeled by the function h of t is equal to negative 16t squared plus 20t plus 6. It says, when will he reach a height of 14 feet? When will he reach a height of 14 feet? Okay, so that means we need to take this 14 and plug it in for the height h of t. So we have 14 is equal to negative 16t squared plus 20t plus 6. Okay. It's asking us, will he reach a height of 14 feet? Okay, so we're going to do this using the quadratic formula to see if that's even possible. Okay, so in order to do this, I have to have my equation equal to 0. So I'm going to subtract 14 from both sides, and I get 0 is equal to negative 16t squared plus 20t minus 8. Minus 8. Okay. Now what I'm going to do, labeling my A, B, and C values, I'm going to plug this in to the quadratic formula. So remember that formula is x is equal to, but in this case our variable is t, so t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So plugging everything in, we get negative b, so negative 20, plus or minus the square root of b squared, so 20 squared, minus 4 times a, which is negative 16, times c, which is negative 8, all over 2 times a. So 2 times negative 16. Okay. We're first just going to check what is under the square root. So 20 squared is 400. So this is 400. And then negative 4 times negative 16 times negative 8 is minus 512. Notice if I combine those numbers, I'm going to get a negative number under the square root. So I'm going to get t is equal to negative 20 plus or minus the square root of negative 112 all over 2 times negative 16. Since I end up with a negative number under the square root, that tells me that I am not going to have a real solution. Okay? That means I cannot continue to solve this problem because any answer I'll get from it is going to be imaginary. So the question, will he reach a height of 14 feet? We would say no. No, he won't reach 14 feet. Okay. Let's see how high that he would reach. So if he can't reach 14 feet, let's try to find the maximum height to see how high he could actually jump. So we do that by using our vertex formula. Okay, so I'm going to have x is equal to negative b over 2a. Okay, and again, we're looking back at this original problem now. We're just seeing what the maximum height is. So negative b, that's negative 20 over 2 times negative 16. That's going to give me negative 20 over negative 32, which simplifies to approximately 0.625. So if I plug in that 0.625 into my problem, let's see what we get. This is going to give us the maximum height that this child can jump. Okay, so plugging in that 0.625, we get a maximum height of 12.25, meaning the vertex here is 0.625, 12.25, meaning the maximum height he can reach is 12.25 feet. So this is another way to prove that he would not reach 14 feet because our maximum is 12.25. Okay. Last part here says, how tall is the trampoline? So looking at our original problem, we have to find out how tall the trampoline is before we even start jumping. So before we even start jumping, that means time is 0. So we're going to be plugging in 0 for t. So we have h of 0 is equal to negative 16 times 0 squared plus 20 times 0 plus 6. The first two terms with the 0 is going to cancel out, and we're left with h of 0 is equal to 6. This tells us that the trampoline is 6 feet tall. And we found that by plugging in 0 for t, Or we could have just looked at the c value of the function. And the c value was 6, so that tells us that the trampoline is 6 feet tall.